When we're solving quadratic equations by using square roots, pay close attention to what type this works for. Okay, so what you're going to do is when you have a quadratic function, so you put it in standard form, and you see that b is equal to 0. When is b equal to 0? What's missing from the quadratic function? Which term of a quadratic function ax squared plus bx plus c is actually missing if b equals 0? The x term is missing. Okay? So when you don't have an x term, that means b is equal to 0. So what we're going to do is we're going to take the ax squared term and we're going to set it equal to the c term. Okay? So instead of it being set equal to 0 in this one, we're going to get the ax squared on one side by itself, the c on one side by itself, and this is only going to work when b is equal to 0, or in other words, there are no x terms. Then we're going to divide both sides by a, because typically we can. And then we're going to take the square root of both sides. So, it's just like any time. Oftentimes we get to skip that first step if it's already done for us. This is one, so that's always the first thing we're going to ask ourselves. Is ax squared set equal to c? So number 1, what do you think? Would that be an ax squared term set equal to a c term? X squared equals 25? Yeah, it would. What's our a value in fact in this one? What's our a value in number 1? It's actually 1, isn't it? And then our c value is 25. Okay, so it says divide both sides by a. You really think we need to divide both sides by a this time? Do we get to skip that step also? Why?
Because dividing by 1 wouldn't.
Yeah, dividing by 1 wouldn't change anything. So we're going to go straight to the third step, which says take the square root of both sides, because we can take the square root of x squared. We can take the square root of 25. What is the square root of x squared? That's x. And what's the square root of 25? 5. And let's go back a little ways in our memory bank, our skill bank, and let's remember what's always true when you take the square root of a number. Does it only have one square root? In other words, is there only one number, one real number, that gives you, when you multiply it by itself, it gives you 25. Is 5 times 5 the only way to get to 25? I got some yeses and I got some no's.
Well, it's not the only way you can get to 25.
By multiplying a number by itself, though, specifically. So is there, Abby, is there another number?
Yeah.
What is it?
Negative.
-5. Isn't -5 times -5 also a positive 25? So we have to dig back a ways, but back a ways we learned that when you take the square root of something, you have a positive and a negative square root. So we would say x is equal to a positive and a negative 5. Or in other words, if we graph this, what would be true? Tell me some things about this, the graph of this. Parallel lines? Is it linear? And do we have 2 equations here? Do we have 2 different things? Uh-oh. We're still in the quadratic function. Isn't this a quadratic function? How do I know it's a quadratic function? It's x squared, it's a degree 2. If it's a degree 2, it's a quadratic function. So what kind of a graph does a quadratic function have? A parabola. So this would be crossing the, well, let's do this first. The parabola would be opening up or opening down? What do you think? It'd be opening up. If we put it in standard form, it'd be x squared minus 25 equals y, or 0. So it's opening up. Where's it crossing the y-axis at? No, the y-axis. What's its y-intercept? -25. All the way down there at -25 on the y-axis. Now, where is it crossing the x-axis at? Positive 5 and negative 5. So what we really have here, if we were to graph this we would have a parabola that's crossing down here quite a ways down at negative 25. It's crossing the x-axis at positive 5 and at negative 5, and it is opening up. There's a parabola for that one. Its solutions are positive 5 and negative 5. Its zeros are positive 5 and negative 5. So this is we've solved that quadratic equation. We didn't work very hard. We didn't really understand what we were doing apparently. Okay? Anybody got questions at the time? Okay, number 2. What do you think? We have to do the first step, set ax squared equal to c? No? Okay, so our ax squared is 5x squared. Our c is 245. There is no x term, so we know b is equal to 0. So then the next step says divide both sides by a. Why in this case would it be really handy to divide both sides by a before we do that third step? Why do you think I even put that step in there? No, you don't really want to try and find the square root of 245. Is 245 a perfect square? No. What else isn't a perfect square? 5 isn't either. So if we can divide both sides, because remember, whatever you do to an equation, if you do the same thing on both sides, you're not altering it, you're just renaming it. So we can divide both sides of this by 5 first, by the a value, and then maybe it's going to become friendlier. So we now have, oops, I missed my squared there and my x, gotta have that there. We now have x squared equals 45?
49.
49, okay, that's what I thought. Which now I'm feeling pretty good about because 49 is a perfect square, isn't it? Okay, so now we do our last step, which says take the square root of both sides. And what is our solution or solutions? Because remember, it can have no solution, 1 or 2. Positive and negative 7. X equals positive and negative 7, and that's just the shortcut way of writing it. Instead of having to write x equals 7, x equals negative 7, this means the same thing. There are 2 solutions. So we really have here the same situation we had before. Its vertex is the y-intercept, I bet. It's going to cross the x-axis at two locations, at positive 7 and at negative 7 this time. It's probably opening up, right? Okay, how about number 3? What's going on there? What do you think we're going to have to do? Yeah, we have to do the first step this time. What do you think would be the slickest way to make that happen? Get ax squared set equal to c. By the way, does it matter? Could it be c equals ax squared? What do you think? Yeah. Sides of the equation can trade places. So what would be the one step we could make this into to get that so it's a ax squared set equal to c? Jacob?
Add 64x squared.
Yeah, let's add 64x squared because then it'll move over to the other side and become positive. And we'll have the 9 by itself, which is our c value. And we'll have 0 plus 64x squared, which is 64x squared. Okay. There's a couple of different ways we can go about this one, okay? Is 64 a perfect square? Yeah. Is 9 a perfect square? Yeah, so in reality, we could jump right to the step that's set, instead of dividing both sides by a, because a is a perfect square, we could just jump right to the step of taking the square root of both sides and finish from there. Let's do both ways, okay? Let's kind of move over here into the margin and say, you know what, if I do it by dividing both sides by the a value, I'm going to divide both sides by 64. And so now I'm going to have that nice little fraction over there, right? So I now have 9/64 and I have x squared over here. Okay, well, that's not really a problem because 9 and 64 are still both perfect squares, aren't they? So we can still, work with it this way. We're going to take the square root of 9 over 64, and we're going to take the square root of x squared. Well, anybody remember what we did when we took the square root of a fraction? What do you do? Not your calculator. What do you do? There you go.
When you square root the non
Yeah, you just square root the numerator and you square root the denominator. So what's the square root of 9? 3. What's the square root of 64? 8. And remember this is what you're going to forget. This is what you're going to typically forget and lose you a whole point on an assessment. There's a positive and a negative 3/8 as our solution. Well, I want us to see that there really is another way to do it also, okay? If you don't like that way, I can give you another option. Because A was a perfect square, C was a perfect square, we could do it one of these two ways. So what I'm going to do this time is I'm going to take the 9 equals 64x squared, and I'm just going to leave it like that, and I'm going to take the square root of both sides right away. What is the square root of 9, did you say? 3. Square root of 64? 8. What did I forget? What's missing?
It shouldn't be squared.
No. Oh yeah, thank you. That's one good catch. Good thing to catch that. It should just be 8x, not 8x squared. What's another? That was a mistake I made. Now what else did I forget, Chase? Sir? Well, I do have to do one more step, but what did I forget before I move on to that step? I said you're going to do it all the time, or no, I didn't say all the time. You're going to find yourself doing this and lose a point.
It needs to be plus and
Yeah, we put the plus and the minus in front of the 3. We don't need to do it on both sides. We just do it on, when we take the square root, notice we've never done it on the x side. We've just done it on the other side. We only need to do it on the one side. We're taking the square root and saying that side square root has a positive and a negative. Now, we're going to do that. We're going to take the positive negative 3 and we're going to divide it by 8 and the 8x and divide it by 8. And we can pull that plus minus. Remember I've always said we can pull that out of a fraction. Pull it out of that numerator and say we have a positive or negative 3/8 because 8 doesn't go into 3 nicely. We're going to leave it as a fraction. And over here we have our x. We get it the same answer, just two different ways. Now, when's the only time that you really want to try to probably use the second way I showed you? When both A and C are what? Perfect squares. Then that's a nice handy time to do it. Okay. Questions? So you pick one or the other. You don't have to do it both ways. Okay. Number 4, what do we do first?
subtract 3.
Subtract 3. We want to get that 3 over there with the 124. So our ax squared is alone. So we now have our 25x squared on the left side, and what's on the right side? 121. Okay. Kind of looks like the last problem. You go ahead and finish this one. You get to pick. By the way, is 121 perfect square? Yeah, it is. Okay, so you pick the one you're going to do. And if something, here, let me remind you of this. If something doesn't go into something nicely, just leave it as a fraction, okay? Don't mess with it. Don't mess with it. And I don't think 25 goes into 121 nicely, so. What am I doing? Same solution I do? Positive or negative 11 fifths. Which, if we were gonna say where that's gonna cross the x-axis on our graph, what is 11 fifths? 2 and 1/5. 2 then 2 tenths of the decimal. Again, we have kind of the same situation. Every one of these, actually, the vertex would also be the y-intercept. Every single one of these. When b is equal to 0, you would find that the vertex is sitting on the y-axis. It's the y-intercept. And it's going to, its zeros are symmetric about the axis of symmetry, which happens to be the y-axis. Okay, anybody have questions before we move on? Okay, then let's go to the back side. Okay, and it says, sometimes the number you are to find the square root of is not a perfect square. What are we going to do then? What if, no matter what you do, you're going to end up taking the square root of something that is not a perfect square? We're actually going to leave it in what's called our simplified radical form. I believe we worked with these back earlier in the year too. If we want to show the exact answer. So simplified radical form, and we'll practice this here. Simplified radical form gives us the exact answer. So if you're ever asked to give the exact answer, you can't put it in your calculator and round it. If we're going to not give if we're going to give an approximate answer, let's put that in here. We're going to give an approximate answer. Then we're going to round to the nearest 100. Okay? We're going to round to the nearest 100. You have to pick somewhere to round to, so we're going to go to the hundredths place. Okay. Is 3 a perfect square? No. Is 81 a perfect square? Yeah, but they both gotta be, don't they? Okay, so let's go to our step that says we already have ax squared set equal to c, so let's go to our step that says let's divide and get that a out of there then right now. Never know, maybe when we divide by that a, we'll end up with a perfect square on the other side. Again, even if it was a perfect square, maybe it'll turn out to be a perfect square again. Never know. So now we have x squared equals, what's 81 divided by 3? 27. Kind of a nice number, but is it a perfect square? No, it's not. So we're going to give the exact answer and the approximate answer, but first thing we have to do is we have to say, well, I got to take the square root of both sides to get x. So since 27, is not a perfect square, I'm going to leave it in simplified radical form. Anybody remember how we did that?
Just leave the square root there.
We leave the radical sign there. If and only if there aren't any perfect square factors in our radicand. 27 is the radicand here. Are there any factors, any numbers that go into 27 other than 1 that are a perfect square? 9 is, isn't it? So the perfect squares. 1, and I said we're going to throw that one out. 4 doesn't go in. Next one is 9. Next one is 16. Next one is 25. Looks like the only choice we have here is 9. So we're going to break this into the square root of 9 times the square root of 3, because 9 times 3 is 27. So we can give each of those factors their own radical sign, and we can say, okay, well then I have a positive or a negative. What's the square root of 9? 3. But I can't take the square root of 3 without approximating it, so I'm not going to if I want an exact answer. This is the one we call our exact. So this is the exact. Right here, simplified radical form. And we have to, you will do this a lot in geometry next year. Okay, so be ready. You have to be able to give it in simplified radical form. Now, I would like you to try something on your calculator. Would you take, don't do the square root of 27 yet. I want you to do this in your calculator. I want you to take 3 times the square root of 3. Would you take 3 times the square root of 3? And if I told you to round that to the nearest hundredth, what would it be? What would that one be?
5.196.
Okay, well, remember, hundredths is 2 places, so you are going to look to the thousands place and see is it big enough to change in the hundredths place. So what happens on your calculators when you do 3 times radical 3? Will you give me what you get there? You get 5? Well, exactly. I just want the next 3 digits. I don't care about the rest of these. Just ditch them. What are these digits? 1, 9, 6. Okay. So is this big enough? This 6 big enough to change this from being 19 hundredths to 20 hundredths? Yeah. So we would say that rounded it is approximately 5.20. 5 and 20 hundredths. Now, and we don't ditch that 0 because that 0 is important there. 20 hundredths, not 2 tenths, 20 hundredths. Now I want you to take the square root of 27 on your calculator. You did the same thing? We better, or we did something wrong. Okay, so that's how we will get the approximate answer. So our approximate, we're going to say x is approximately equal to a positive or negative, and we already said that has to be rounded to 5 and 20 hundredths. So there aren't 4 solutions here, guys. There aren't 4 solutions, there are still only 2. 2 of them, the first way we gave it in its exact form, in case that's the way they ask us for it, or the second way we gave it was in its approximated form, in case that's the way they asked us for it. Okay? So in other words, this one would be really hard to tell where it's crossing the x-axis. It would be a little bit beyond 5 and a little bit beyond negative 5, but it would be hard to get be able to tell from a graph where it was actually crossing. Okay. So, how about the next one? Let's try that one. What are we going to do first? Subtract 64. We need the ax squared set equal to the c value. So we have 2x squared equals negative 64. Is 2 a perfect square? No, so we're going to divide by it, aren't we? Let's divide by it. Let's say 2x squared is going to get divided by 2. Negative 64 is going to get divided by 2. And I'm going to have x squared equals what? Negative 32. Oh shoot, I had what looked like a perfect square on the other side, and now I just ruined it. Oh well. 2 wasn't a perfect square either. Okay, so next I'm going to do what? Square root both sides. And how do you feel about that? No, it's a no-no. Why? Isn't a perfect square? Well, then what we do is we give an exact answer in simplified radical form, and we give an approximate answer rounding to the nearest hundredth. Isn't that what we do? Oh, nothing times itself is a negative, Abby says. So in other words, if you take a negative times a negative, if your square root is negative, a negative times a negative is a positive. And if you take a positive times a positive, that's a positive. So didn't we learn, in fact, would you try it right now? Would you try and take the square root of negative 32 on your calculators right now? What does it do? Domain error, something, it just doesn't let you do it, does it? What are we going to say? No real solutions. And we're going to say real because here's the deal. There are solutions, they're just imaginary. And imaginary doesn't mean you get to make them up. It means there's another way to find them in what's called the complex number system, but you don't learn that until advanced algebra. So we're going to say there are no real solutions. So in other words, tell me what would this parabola be doing? Would it be a flat line? What is it, for there to be solutions, what does the parabola have to do?
Zeros.
Has to have zeros. And if it has zeros, that means it does what?
Crosses the x.
Crosses the x-axis. Is this one gonna cross the x-axis? No, it's not. So if it was in standard form to start with, so tell me something about this one. Is it gonna open up or is it gonna open down? It's gonna open up. It's gonna open up. And its vertex is gonna be, it's gotta be where? Where does the vertex have to be if it doesn't have any solutions? It has to be above the x-axis. So this parabola is sitting somewhere above the x-axis, opening up, and it's never going to cross the x-axis. If this isn't saying there's no parabola, that isn't what no real solutions mean. It doesn't mean there's no parabola, it just means that parabola is never going to cross the x-axis. And so someday you will learn, how am I going to find the solutions for something like that? Okay? Okay, let's do one more here. I think this is our last one, number 7. What should we do here? What do you think? I think we're going to maybe have to make 2 moves to get it in our ax squared equals c form. And no matter which way you do it, there's still 2 moves. So what would be the first thing you might want to do? What do you want to do first?
Add 5x.
5x squared, add it, so it's positive on the other side. Okay. And now we'll have 125 equals 25 plus 5x squared. Would be our next move. Subtract 25, we want that ax squared by itself. And so now we have 100 equals 5x squared. I just hate when one of them is a perfect square and the other one isn't. Wrecks it, doesn't it? So what are we going to do next? Now we have our ax squared set equal to our c value. What should we do next? Divide by the a value. So we'll divide both sides by 5, the a value. $100 divided by 5? 20. And we got x squared on the other side. Okay. Now that we have it to that point, we're ready to say, okay, I think I'll take the square root of both sides now. Because I need to get x out of x squared, that will help me do that. And then I'm going to say, okay, I got a positive or a negative. 20 is not a perfect square, right? But the next question we have to ask ourselves for our exact answer is, should we leave it as the square root of 20 then? Or should we take it and say, oh, it's got a perfect square factor in it though? Does this one have a perfect square factor in it? Remember the perfect squares, we're going to throw out 1 because 1 isn't going to get us anywhere. The next perfect square is 2 times 2 is 4. The next perfect square is 4. Is 4 going to 20? Yeah. The next perfect square is 3 times 3 or 9. Is 9 going to 20? No. The next perfect square is 4 times 4, which is 16. Is 16 going to 20? No, so it's looking like the largest perfect square we can get out of there is 4. So we're going to divide this up into the square root of 4 times the square root of what? 4 times what is 20? 5. So I'm going to go over here, and I'm going to say that the exact answer is a positive or negative what? 2 times the square root of 5, or in other words, we can just write them beside each other like that, 2 radical 5. A positive or negative 2 radical 5. That's what we call our exact answer in simplified radical form. We simplified it by dividing out that perfect square of 4 and taking its square root. And then the approximate is going to be, so we have the square root of 20 equals x. So the approx is a positive or negative, and we round to the nearest hundredth. So go ahead and put the square root of 20 into your calculator. And what's The first 3 digits after the decimal point. 472, is that everybody has behind the decimal point, 472? By the way, you gotta know how to take the square root on your calculator, so if you don't today, you better learn. Is it 472? So that's 4700s here with that 2 in the thousands place. Is the 2 big enough to make the 4800s? No, so we're gonna approximate it to 4.47 then, right? Everybody agree? Let's go with Jacob's, what he had there. Now, would you do one thing? This is how you'll know if you did somewhat of a good job maybe, of putting it in simplified radical form, right? Would you take 2 times radical 5 and see if it gives you the same number? 2 times radical 5 gives you the same thing. Got thumbs up from Jacob. Head nods, okay. Okay, doesn't mean, at least you didn't simplify that part wrong. You maybe could have done more simplifying, but no, this one we could not. But you can always use that also to help you out. Okay, this is what you're doing in your homework. Anybody have questions at the time?